Download this code from codegive.com, link in the description below. Debugging Troubleshooting, a comprehensive guide with code examples. Debugging is an essential skill for any programmer. It's the process of identifying, locating, and fixing errors, bugs, in your code. Effective debugging saves time, frustration, and prevents your application from crashing or behaving unexpectedly. This guide provides a comprehensive overview of debugging techniques, strategies, and tools, complete with code examples to illustrate the concepts. Understanding the debugging process. Debugging is not just about randomly trying things until your code works. It's a systematic process that involves 1. Observation * noticing the problem. What specifically went wrong? What were you expecting? 2. Reproducing * making the problem happen again consistently. This ensures you're actually addressing the same issue each time. 3. Isolating * narrowing down the location of the bug within your code. This is often the most challenging step. 4. Understanding * figuring out why the bug is happening. What assumptions were wrong? 5. Fixing * implementing the necessary code change to correct the error. 6. Testing * verifying that the fix works and doesn't introduce new problems, regressions. 2. Types of errors. Before diving into techniques, it's helpful to understand the different categories of errors. Syntax errors * these are errors in the grammar of the programming language. The compiler or interpreter will usually catch these before the program even runs. Examples include missing semicolons, unmatched parentheses, and misspelled keywords. Runtime errors * these errors occur while the program is running. They often arise from unexpected input, division by zero, accessing invalid memory locations, or resource exhaustion. These errors can cause the program to crash. Logical errors * these are the trickiest to find. The program runs without crashing, but it doesn't produce the correct results. This is because the logic of the program is flawed, even though the syntax is correct. Examples include incorrect calculations, wrong conditional statements, or flawed algorithms. 3. Debugging techniques and tools. Here's a breakdown of common debugging techniques and the tools you can use to implement them. Print statements, aka logging. This is the simplest and often the most effective method, especially for debugging logical errors. You strategically insert print statements, or console.log in JavaScript, system.out.println in Java, etc., to display the values of variables and the flow of execution at various points in your code. Example, Python. Output *. Benefits *. Easy to implement. * works in almost any environment. * good for understanding the flow of execution. Drawbacks * can clutter your code with temporary print statements. Remember to remove or comment them out after debugging. * not suitable for complex debugging scenarios. Debuggers, IDE debuggers, command line debuggers. Most IDEs, integrated development environments, have built-in debuggers, which offer powerful features for inspecting your code during execution. These features typically include breakpoints you can set breakpoints at specific lines of code, and the debugger will pause execution at those points. Stepping you can execute your code one line at a time, step by step. Variable inspection you can examine the values of variables at any point during execution. Call stack you can see the chain of function calls that led to the current point in the program. This is helpful for understanding the program's execution path. Asterisk conditional breakpoints. Asterisk breakpoints that trigger only when a specific condition is true. Example, debugging in VS Code with Python. 1. Install the Python extension for VS Code. 2. Set a breakpoint. Asterisk click in the left margin next to a line number to place a red dot, breakpoint. 3. Start the debugger. Asterisk go to the Run and Debug view, Ctrl+Shift+D or CMD+Shift+D, configure a Python debugger. VS Code will prompt you if you haven't already, and click the Start Debugging button, the green play button. 4. Step through the code. Asterisk once the debugger hits the breakpoint, use the stepping controls, step over, step into, step out, in the debugger toolbar to execute the code line by line. 5. Inspect variables. Asterisk the variables pane will show you the current values of variables like n, I, and result. Command line debuggers, example pdb in Python, gdb in C/C++. These are text-based debuggers that you run from the command line. They offer similar functionality to IDE debuggers, but with a command line interface. Example, Python using pdb. When you run this code, the program will stop at the pdb.set_trace line, and you'll enter the pdb debugger. You can then use commands like *n, next execute the next line. *s, step into a function call. *c, continue execution until the next breakpoint or the program ends. *p variable, print the value of a variable. *q, quit exit the debugger. Benefits of debuggers. Precise control over execution. Powerful variable inspection capabilities. Helpful for identifying the root cause of complex problems. Call stack analysis. Drawbacks. Can have a steeper learning curve than print statements. Requires setting up the debugger for your environment. See assertions. Assertions are statements that check if a condition is true at a particular point in your code. If the condition is false, the program will raise an assertion error, or similar exception, indicating that something unexpected has happened. Example, Python. Benefits. Help catch unexpected conditions early. Can be used to validate assumptions about data and program state. Make debugging easier by pinpointing the location of errors. Drawbacks. Assertions are typically disabled in production code, for performance reasons, so they're primarily useful during development and testing. They only tell you that something is wrong, not why. Code review. Having another developer review your code can be incredibly helpful for catching errors you might have missed. A fresh pair of eyes can often spot logical errors, potential bugs, and areas for improvement. Explain the purpose of your code clearly to the reviewer, including any specific constraints or assumptions. Unit testing. Writing unit tests is a crucial part of software development. Unit tests are small, isolated tests that verify that individual functions or components of your code work as expected. By writing unit tests, you can catch bugs early in the development process and ensure that your code is robust. Example, Python using Unitest. Benefits. Helps catch bugs early in the development cycle. Improves code quality and maintainability. Provides confidence that your code works correctly. Facilitates refactoring, making code changes without breaking functionality. Drawbacks. Requires time and effort to write and maintain. Cannot catch all types of bugs, example integration errors. F. Version control, Git. Using a version control system like Git is essential for managing your code changes. Git allows you to track the history of your code, revert to previous versions, and collaborate with other developers. If you introduce a bug, you can easily identify the changes that caused it by examining the commit history. Git bisect is a powerful command specifically designed for finding the commit that introduced a regression. G. Static analysis tools *. Static analysis tools analyze your code without actually running it. They can detect potential bugs, security vulnerabilities, and code style violations. Examples include linters, example Flake8 for Python, slint for JavaScript, and static code analyzers, example SonarQube. H. Specialized debugging tools *. For certain types of problems, specialized debugging tools can be helpful. Memory profilers help identify memory leaks and excessive memory usage. Example Valgrind for C/C++, memory profilers built into IDEs. Performance profilers help identify performance bottlenecks in your code. Example C profile in Python, profiling tools in IDEs. Network analyzers, Wireshark help diagnose network-related issues. 4. General debugging strategies. 1. Understand the error message *. Read the error message carefully. It often contains valuable information about the type of error and where it occurred. 2. Reproduce the bug *. Make sure you can reliably reproduce the bug. This is crucial for verifying that your fix works. Write a test case that specifically triggers the bug. 3. Simplify the problem *. Try to isolate the bug by creating a minimal example that reproduces the error. This will make it easier to understand the cause of the bug. Reduce the complexity of the input data or the program's flow. 4. Divide and conquer *. If you have a large program, break it down into smaller, more manageable pieces. Test each piece individually to isolate the bug. 5. Rubber duck debugging *. Explain the problem to someone, or even to a rubber duck. The act of explaining the problem can often help you identify the solution. 6. Don't make assumptions *. Carefully examine your assumptions about how the code is supposed to work. Often, the bug is caused by an incorrect assumption. 7. Search the web *. Use search engines to look for solutions to common problems. Chances are someone else has encountered the same bug before. 8. Use a debugging journal *. Keep track of the steps you've taken to debug the problem, the results of your tests, and any insights you've gained. This will help you stay organized and avoid repeating the same mistakes. 9. Take a break *. If you're stuck on a bug, take a break and come back to it later with fresh eyes. 10. Write clean code *. Clean, well-formatted code is easier to debug. Use meaningful variable names, comments, and consistent indentation. V. Debugging common error types, examples. A. Index error, Python, or array index out of bounds exception, Java. This error occurs when you try to access an element of a list or array using an invalid index, an index that is too large or too small. Debugging *. Check the index *. Make sure the index you're using is within the valid range, 0 to len, my_list, 1. Verify loop conditions *. If you're using a loop to access the elements of the list, make sure the loop condition is correct. B. Type error, Python, or class cast exception, Java. This error occurs when you try to perform an operation on a value of the wrong type. Debugging *. Check variable types *. Use the type, function, Python, or the instanceof operator, Java, to check the types of your variables before performing operations on them. Asterisk cast variables asterisk if necessary, use type casting to convert variables to the correct type. See name error, Python, or null pointer exception, Java. This error occurs when you try to use a variable that has not been defined, Python, or when you try to access a member of a null object, Java. Debugging asterisk. Asterisk check variable names asterisk make sure you've spelled the variable name correctly. Asterisk check variable scope asterisk make sure the variable is defined in the current scope. Asterisk initialize variables asterisk make sure you've initialized the variable before using it. D. Infinite loops asterisk asterisk. These can freeze your program and consume all available resources. Debugging asterisk. Asterisk identify the loop asterisk use print statements to confirm that the loop is indeed the source of the issue. Asterisk analyze the condition asterisk ensure that the loop condition will eventually evaluate to false to terminate the loop. Asterisk step through execution asterisk use a debugger to step through the loop iterations and observe the values of variables involved in the loop condition. 6. Advanced debugging scenarios. Asterisk multi-threading debugging asterisk debugging concurrent programs can be challenging due to the unpredictable nature of thread execution. Debuggers often provide features for inspecting threads and setting breakpoints within threads. Asterisk remote debugging asterisk debugging programs running on a remote server or device. This typically involves configuring the debugger to connect to the remote machine. Asterisk debugging asynchronous code, JavaScript debugging asynchronous code, using promises, async/await, can be tricky because the execution order is not always sequential. Debuggers often provide features for stepping through asynchronous code. 7. Conclusion. Debugging is a crucial skill for every programmer. By understanding the debugging process, using the right tools and techniques, and following best practices, you can effectively identify and fix errors in your code, saving time and frustration. Remember to be patient, persistent, and methodical. Over time, debugging will become a natural and essential part of your development workflow. Practice makes perfect. Happy debugging!